numbers. What a nice guy I am. Look at that. That's pretty cool. Are you okay on where the 1, the 3, and the negative 1/3 are coming from? We're taking the point that I've given you, we're taking the slope that you have found, and we're now making the equation of the line that goes through that point with that slope. Not just if you're out with that one. Okay. So we have our -1, that's -1. We have our negative 1/3, that's your slope. We have our -3, that's the 3. If we distribute, we'll get negative 1/3 x, and then what? Plus? Plus 1. Very good. We're almost done. If we add 1 to it, y equals negative 1/3 x plus 2. Very cool idea. This line will intersect that curve at one spot. And it's going to do it at that point. So that is the tangent line to that curve at that point. It's kind of a cool thing. If you want to just talk about the slope of that curve at that point, well, that's the slope of the curve at that point. If you want to graph a line, that's the line. It's kind of neat. How many people feel okay with this so far? Now, the next question is, if I change points, does my slope change? Does my equation change? Yeah, they're all going to be different. Well, that's going to be annoying, because if I ask the next question, okay, find the tangent line to the point, let's see, 9 1/3. Then I ask, how about 2 3/2? Then I ask some more. You'd have to do this over and over and over and over again to find it for any point, right? Maybe we can be a little bit smarter and do it once and for all. Perhaps we could find the equation for the slope and then just plug in the x values. Would you like to see a way to do that? Yeah. So in other words, maybe I don't want to deal with a specific point. I want to say I want to find the slope of this function at any point. That's what I'm going to show you how to do now. So let's find the slope of the tangent lines forgot my L. Find the slope of the tangent lines. That just means the slope of the curve to y equals the square root of x at any point. At any point. Well, let's go through it. You know that ultimately what we want to do is fill out this equation. We know that slope equals the limit as h goes to 0 f of x of 0 plus h minus f of x of 0 all over h. You with me? Now x of 0 stands for a specific point, does it not? If we erase that f of x of 0, we're going to find it for any point x. You can use x of 0 if you want to. I think the book uses that as well. But you don't necessarily have to if we were to be in general, for any general point. So, well, let's see. Can you tell me then, let's figure these things out just like we did before. Can you figure out what f of x is and what f of x plus h is? Let's try to fill this out. Then we'll make a small substitution to there, just like we did right here. And then we should be able to solve this thing out, provided we can eliminate the h. Let's try that together. So everyone, let's look up here at the board. What is our f of x? What's that do for us? So what was it? Square root of x. Very good. Yeah, that's because it says y equals square root of x. That is our function. So f of x is square root of x. So far, so good? Now, how about f of x plus h? f of x plus h. Is it f of x plus h? Like that. Is it f of x plus h, or is it f of x plus h? So what that says to you is x plus h you cannot separate. Right now what I've done is I've separated the x and the h. Do you see that? This is not the square root, this is not f of x plus h. This is f of x plus h. How do I find, let's compare it. So this is wrong. Leave that on your paper, just scratch that out. That is not the correct thing. What is the correct thing? If I want to input all of x plus h into my variable f of x. This is a composition, folks. You got to know how to do compositions. That's why we spent some time on it earlier. It's not square root of x plus h. It's what?
X plus h.
Not just x plus h. That would be
Square root of x plus h.
It's the square root, sure. And it says, take this whole thing, put it into the variable. Take the whole thing, put it into the variable. It's square root of x plus h. Notice the slight difference. It doesn't look that different, right? But the square root stops here and it doesn't stop there. This is the square root of x plus h. How many people see the difference there and feel okay with it? Is it important to have that difference? Yeah, it really is. Okay, are we ready? Can we make the transition? Yeah, we got it. We got everything we need. We got f of x plus h. Got it. We have f of x. Got it. H doesn't change. On your own, why don't you plug that in? Make the substitution. See what you get. I'll do it on the board at the same time. I always like to put this little tail on my square roots to show me where my square root stops. That way I know it's after the h. I would hate for you to keep doing your steps, right? And this happens. First step, second step, third step, fourth. Oh, now all of a sudden it's gone, right? That would suck. Or it'd get longer and longer and longer and then it's covering the whole thing. Don't do that. Just make sure you know where your square root starts, stops, and what it includes. So f of x plus h, great. Then we have a minus sign, and we have f of x. F of x was square root of x. All over h. You got that in your paper. All right, good deal. Now, oh my gosh, how do we solve it? Just give up. Let's just go home. This is pointless anyway, right? Now, if you plug in 0, you're going to get 0 over 0. You see it? 0, 0. That's a problem. So your whole goal here is to get rid of the h here. That's your goal. Now, there's of course ways to do it. In fact, I've shown you a problem quite similar to this, involving those square roots. Do you remember?
Multiplied by the conjugate.
Do you remember what the conjugate is? Whenever you have square roots like being subtracted, or square roots in any case, you're taking a limit, one great idea.
Change the sign.
Yeah, change the sign, multiply by the conjugate. That's always a good idea to do. Do that right now. Multiply. Wait, is it just the numerator or both the numerator and denominator? Both. Multiply it by the conjugate right now, okay? You're going to need to distribute the numerator, but do not distribute the denominator. You're trying to get rid of the h on the denominator. If you distribute it, you'll have to refactor it anyway. Hey, does this sign change? I know this one does. Does this sign change as well?
No.
No.
No, okay, good. Remember, we have parentheses here, which means you're going to have to distribute. And we have parentheses here, but what I told you is you don't want to distribute where you're trying to get rid of something. Right? You're trying to get rid of that h, so don't distribute that, otherwise you'll have to refactor it. So in our case, our limit, keep writing limit, is denominator again. Keep it the same. And you'll see why in just a second. But if you distributed the numerator correctly, hopefully you got this. No more roots. Do you have any roots? Then you probably did right. Numerator, you're going to get x plus h, because the square root times itself gives you the radicand. That's the inside. So we have our x plus h. That's great. Our middle terms are gone. You're going to get plus root x plus h minus root x plus h. It's fun to say. And then lastly, you're going to get minus x. Show of hands how we made it that far. Great, what happens? Yeah, we have positive x, negative x. That's kind of what you need to happen, right? Geez, I told you to get it out ahead of time. What's the matter with you? So those are gone. Do you need a tissue? Yeah, I don't have one.
Thanks. Thanks for the offer.
Anybody have a tissue?
It's fine.
Good. I don't think anyone else has one either.
You're so considerate.
Thank you. I care about my students. You're paying my salary. Suckers. No, I'm just kidding. Totally joking. I love you all. Anyway. Please subscribe. 20,000 views.
What happens at 20,000?
Nothing. Just want to get there. First one go off. What happens now? H's, sure. H's. Do you have anything left on the numerator?
One.
Oh, how sweet. Thank you. Look at that. So we have now a limit . H goes to 0. Can we let the h go to 0 and be okay? If we do, we get x plus 0, which is still x. Square root of x, that's okay. Plus square root of x, that's okay. So we're okay. If we let the h go to 0, what we end up getting is, notice no more limit. You have 1 over square root of x plus 0 plus square root of x. No more limit because I allowed the h to go to 0. When you're all said and done, what is that going to, what's that going to be? I'll give you the 1. 1 over what?
2 squared of x.
Not x, right? A square root of x plus a square root of x doesn't equal x. That's multiplied. But a square root of x plus square root of x gives you
2 square root of x.
what did you just find? What is this? What's this weird thing that we just found?
Slope.
Oh, this is a what? That's a slope. What you just found is a slope. You found the slope of this. Well, where'd it go? You found the slope of that. That's crazy. Look at that. This thing right here is the slope. It's the slope of this curve, which looks like this thing. That's how that curve looks. It's half of a parabola on its side, right? What you've just done, you've found the slope at any given point, which is constantly changing. That's pretty impressive. So here's my point. Could you find the slope at the point 4, 2? Could you find the slope at the point 16, 4, 9, 3, or anything else for that matter? Could you find the slope of that? Sure, even weird numbers. Find the slope at the point 7. You could do it. It'd be 1 over 2 times the square root of 7. You could find the slope at that. All you've got to do now is plug in the x coordinate. It will give you the slope of that curve, this curve, at that point. Did you get the idea? So if I say find the equation of the tangent line now for these points, well, you can do it very easily. So never forget that what we're actually doing, we're finding the slopes of curves. This thing is the slope of that curve, this curve, at any point x. So if I had asked you this question, so with a specific point, you'd right now be plugging in which one, the 1 or the 3? You'd be plugging in the 3. Now, of course, 3, 1 is not on this curve.